Why does a figure skater spin at twice the speed it was at before when all they do is bring their arms in? Or why is it so much more difficult to catch a tennis ball compared to a ping pong ball? These are all examples of angular and linear momentum inside of the real world. Let's first start off by talking about what angular momentum is. Angular momentum can be represented by L, and it tells us how difficult it is to stop an object from orbiting around the center. Angular momentum has three factors, and the first one is mass. For example, this tennis ball has a mass of around 50 grams. The second factor is velocity. For example, when I throw this tennis ball up, it has a velocity of about 2 meters per second. Velocity also includes direction, but we're not focused on that right now. The third and final factor is the distance from the center. For example, when this tennis ball is orbiting around this center, the distance from the center is 5 meters. Mass can be represented by m, velocity can be represented by v, and the distance from the center can be represented by r. We can use those three to find the formula for angular momentum, and all you have to do for that is just multiply all three of those factors I just mentioned. We can use these to truly understand how a figure skater can spin at twice the speed it was at before when all they do is bring their arms in. Let's start with this tennis ball. It has a mass of 50 grams, and the circle it's orbiting around has a radius of 5 meters. And we want to find what velocity is because that is unknown. We know that the angular momentum is 250 kilograms times meters squared over seconds. So we can first start off by multiplying the radius times the mass times the unknown velocity equal to 250. This is essentially 250 v, and that's equal to 250. We can divide 250 on both sides to isolate v, to find that v is equal to 1 meters per second. Now we can do the same for this tennis ball. This tennis ball orbits around a circle with a radius of 1 meter, and it also has a mass of around 50 grams. And we're also trying to find the unknown velocity, and the angular momentum is the same as the before ball. So for this ball, it's orbiting around a circle with a radius of 1 meter. Its mass is 50 grams, and the velocity of it is unknown, and the angular momentum is 250. This is essentially 50 v is equal to 250. We can divide 50 on both sides to once again isolate v. This makes v equal to 5, so we can put 5 meters per second. This accurately explains how a figure skater can spin quite faster when all they do is bring their arms in, because the mass stays constant whether their arms are in and out, and their angular momentum always stays the same. So when their radius decreases, the velocity is to balance out by increasing. Let's now begin talking about linear momentum. Linear momentum is represented by p, and similar to linear momentum, it tells us how difficult it is to stop an object from moving. The factors are also very similar to angular momentum, as the two factors are velocity and mass. The only thing we are doing is getting rid of the factor radius or distance from the center. The formula is also surprisingly similar to angular momentum, as it's simply just multiplying velocity and mass. We can use these to understand why it's so much difficult to catch a ping pong ball compared to a tennis ball, or more specifically, why you feel so much more force when a ping pong ball hits your hand compared to a tennis ball. Both of these balls are going to be traveling at the same velocity, and But the tennis ball has a mass of 50 grams, while the ping pong ball only has a mass of 2.5 grams. They're both going to be hit at the same speed. But first, let's do the math. We can first find the linear momentum. So we'll multiply n times v for the tennis ball. 50 times 5 is equal to p. So 250 is equal to p. So our linear momentum is 250. And then for the ping pong ball, we can do 2.5 times 5 is equal to p. And 2.5 times 5 is 12.5, which equals p. So obviously the force for the ping pong ball is much less compared to the tennis ball. And if I hit the ping pong ball at 5 meters per second, I feel very little force. But if I hit it at the same speed for the tennis ball, I feel a lot more force. This can explain why you feel more force with the tennis ball compared to a ping pong ball. Thank you for watching my video about angular and linear momentum, and I hope that you have left with a much more conceptual understanding of angular and linear momentum and their applications inside of the real world. Thanks, y'all.